Hi all. Today we will talk again about HDR games setting. In part, today's video will be a continuation of my previous video about problems of HDR gaming. So if you haven't watched it yet, then I don't understand why you haven't done it yet and at the same time, didn't like and subscribe to the channel. So, I have recorded several videos about HDR settings in different games. But often the principles of setting up different games are associated with the same procedures. Only the quantity and options name changes. But some gamers ask for exact numbers for their TV and think that other people's settings will help them too. And I realized that not all people understand what they are setting up and why these settings are generally needed. Let's try to figure it out. Let's start in order. What exactly is HDR? Surely you have seen or read somewhere but never received a clear answer. Probably HDR is image is even brighter, even richer in colors, light is even lighter and dark is even darker. Yes, but this is only partially true. It is all the more confusing that the term HDR exists in photography and there it means something completely different. This has nothing to do with HDR video. Well, imagine a picture of the world around you. To encode information about scene, you can simply split it into two components, black and white part and colors part. Let's take a look at this ball for example. It has a color component and a black and white component. In fact, this definition is not entirely correct. Because by white we mean not a color, but maximum luminosity, for example, light from the sun, and by black, we mean minimal luminosity, that is, absolute darkness, for example, a shadow. But for simplicity of explanation, we will denote it as follows. By the way, this is the dynamic range. Let's go back to our image. Here is its black and white component, or more precisely, information about brightness. Let's imagine a gradient from black to light. So how do you encode information about this? Very simple. Let's divide into segments. Now we can say that a certain pixel luminosity has a value equal to a specific segment luminosity. The entire gradient has a maximum luminosity of 100 nits and is divided into 255 segments. This is SDR. Since there are not so many segments, they may not be enough to convey information about all the details, otherwise there will be too high discreteness. Therefore, the maximum luminosity was limited to only 100 nits. But the difficulties are just beginning. The division into 255 segments that I talked about is called full dynamic range. But there is also a limited range. Imagine the same gradient with a maximum luminosity of 100 nits. But his absolutely dark value is not 0, but 16 segment. And the maximum is 235. It's crazy, right? Why does this exist? In fact, even though it is now 2021, limited dynamic range is very common. Of course, in theory, the full range is better since it has more segments. But the differences are minimal. But here comes the problem. Your display needs to know the video in what range it is currently displaying. If the TV considers that the video is encoded in a limited range, but it actually has a full range, then you will lose absolutely black and absolutely light, and all intermediate values will be out of place and are transformed to incorrect values. Let me show you with an example. Watching streams or YouTube videos, you've probably seen something like this. The video seemed to have lost contrast and the colors were washed out. But on top of an incorrectly encoded video, there may be a webcam with a correct image. Always look at black color when viewing. If it is not black color, but more gray, then the video has problems with dynamic range. Or the opposite situation. Video is recorded in a limited range, but the display is set to full range. In this case, excessive black and excessive light will be added to the image, and again all intermediate values will be distorted and not correct. The image will be over-contrasting. By the way, the situation with the incorrect range is very funny. You can see some of the official game trailers look too dark or unnaturally faded. You may have seen the topics of discussion, why after uploading to YouTube, the video loses in contrast and the gamma becomes incorrect. One of the reasons, YouTube thinks the video is recorded in a different dynamic range. But why did I talk about SDR? After all, the video title is about HDR. The fact is that the situation is similar with HDR. Only for HDR, our gradient can be divided, not into 255 segments, but into 1023. In this case, you do not need to limit the maximum luminosity to 100 nits. This number of intermediate segments allows you to encode luminosity up to 10,000 nits. That is, you can convey the image in the most natural form with natural luminosity, as well as convey all the intermediate details of the image as possible, for example, objects in the shadow. This is called HDR, which means high dynamic range. But I talked about full and limited range earlier. Many people forget, but these concepts are true for HDR too. A minimum of 0 and a maximum of 1023 is the full dynamic range. The limited range for HDR is a minimum of 64, a maximum of 940. Now, remember what happened to SDR if the video signal at the input to the display is in a limited range and the display is set to full range. Yep. It will be the same now. The colors are washed out and the image has lost contrast. The most common question that gamers ask when setting up HDR is, why does the image have washed out colors and low contrast? This is the answer. This is a very common reason. There is still one moment that can be confusing, which is not specified anywhere. For example, on a PlayStation in SDR mode, you can choose full or limited dynamic range, but for HDR with some displays, this setting simply does not work. HDR images are always displayed in a limited range. The gamers may also have a misunderstanding why watching HDR movies, for example, in streaming services, there are no problems with the HDR image, but when the HDR console is connected, the image colors looks wash out. Answer: because an HDR movie can be shown in full dynamic range, while a console game is shown in a limited range. Conclusion: use different profiles of your TV settings for movies and games. And as for the settings of the full and limited range, as I already said in the video problems of HDR gaming, this option can be called differently for different TVs. Maybe dynamic range, maybe black level. Hack your TV settings carefully and set the limited range before running the HDR game settings if the full limited image looks the same when you toggle the console option. If you set the mode to auto to console and TV, then make sure 100% that the TV switches to the correct range. As for the settings in the console, I don't know how the situation with the full and limited range is on this box and PC, since I mainly use the PlayStation. Most likely similar. A PC should, in theory, have a lot of flexibility with a video driver. And so, we learned about the dynamic range and what to look out for in the first place if you see washed out colors and low contrast in the game. But of course, this is not the only one possible reason. But since we learned about our black and white component of the image, then let's learn about the color. It's much easier. In SDR, the Rec 701 color space is now commonly used. That is the range of color shades that can be encoded and displayed for the viewer. Of course, there are many more possible color shades. HDR usually uses wider ranges of DCI-P3, Rec 2020, etc. That is, you can see color shades as natural as possible and close to the original image source. Of course, on the other hand, there is a limitation. This is your TV. Your TV cannot physically show color shades beyond the capabilities of its matrix, even if very wide colors are encoded in the video. In your TV spec you can find these strange characteristics, for example, 90% of the DCI-P3 range, 70% of the Rec 2020 range, etc. This leads to another conclusion: the same video content looks different on different displays. There is one more color characteristic that you should be aware of. Remember, you played some kind of game or watched a stream or video and noticed, somewhere in the sky or in the shadows, where one shade of color turns into another, a ladder effect is noticeable. That is, abrupt discrete transitions. This is especially noticeable in CGI cutscenes of games. SDR uses 8 bits to encode color, while HDR10 uses 10 bits. That is, the transition from one color to another will be less noticeable. Dolby Vision uses 12 bits, which in theory will give an even better result. And so to summarize, HDR allows you to show the images accurately and as close to the real image as possible, ignoring the limitations of the SDR mode, that is, more colors, greater luminosity of light sources, more details in midtones, for example, in the shadows or on a bright sky, smoother color transitions, etc. You can now move on to the topic of this video. HDR settings in games, how to set it up correctly, and why it exists at all. Imagine, a conditional game developer sits and creates a game. He achieved an impressive result. On his monitor, which has a maximum luminosity, for example 800 nits, the game scene looks great. The colors, the contrast, the blood, the reflections on the golf club, they all look amazing. And so he sells the game to you. You run it on your TV with a maximum luminosity of 500 nits and you see a strange thing. The image looks terrible. You do not understand what the matter is and go to your friend. You start the game on his TV with a maximum luminosity of 1000 nits and you see a different image, but also ugly. In the video about problems of HDR gaming, I talked about the main problem with HDR is displays. They all have different characteristics. In order for you and your friend to see the correct image as close as possible to the one that the developer intended, the luminosity range with which the console displays the game on your display must be transformed to the luminosity range of your particular TV. In this example, you have to reduce the luminosity level of the game from 800 nits to 500 nits available to your TV, and your friend should increase the value from 800 nits to 1000 nits available on his TV. This is what it looks like. On the left side, the HDR signal source is a game console that outputs a game with a certain level of luminosity. On the right, our TV receives an HDR signal and has a certain maximum luminosity. You must decrease or increase the luminosity range of the input signal to match the luminosity of your TV. That's what HDR calibration settings are for. There is also a lot of confusion about the settings. I talked about this in the last video. Calibration settings can be in the system of your console like the PlayStation and Xbox. They can be in the game settings, or HDR settings may not be at all. That is, the game outputs an image of a fixed luminosity level, and you cannot change this in any way, except using the tone mapping function of your TV. Consider all cases, if the game is an exclusive of this platform, and there are no HDR settings in the game itself, then most likely the game uses the system HDR settings. Try to change them and check if the game image changes. Cross-platform games is highly likely to have its own settings. In the last video, I already said that it is often much easier for developers to write universal program code that is easy to port to all platforms. And force the project to use the system settings of the console can be difficult, expensive, or impossible due to the peculiarities of the game. So with the HDR settings in the console system, there should be no problems. You set the luminosity to the maximum and then the minimum for your display. This must be done after the TV settings. If you have adjusted the levels and then change the TV settings, this is wrong. This also applies to DTM and HGIG settings, but we will talk about this later. With peak brightness settings, everything is very simple. One square is shown with a maximum luminosity of 10,000 nits, but of course your TV is not capable of showing such luminosity. Let's say your TV has 800 nits luminosity. You increase the value in steps of 100 nits, and after 8 steps the luminosity will equalize. This will tell the console that your TV's luminosity is 800 nits. By the way, have you wondered the 3 steps are for? Why is the maximum luminosity adjusted twice? Why one step with a light background and another one with a dark one? Yes, it turns out there are 2 maximum brightness. The HGIG specifications describe 2 parameters. One is the luminosity of 100% of the screen area, and the other is the luminosity of 10% of the screen area. In other words, the luminosity of a small object on the screen and the luminosity of a large object occupying almost the entire screen. Yep, it turns out that these are different parameters and they are not at all the same. Try going to ratings.com and looking for the specs of your TV. The luminosity of 100% of the screen area is usually below 10% of the area. Because it is easier for your TV matrix to illuminate a small area of the screen than to illuminate the entire screen. The third parameter is black level and is equally important. Remember our ball from the example. Here are 2 balls. The color of one is very fade, but if we decompose it into color component and black and white component, then we will see that everything is fine with the color. Black level problem. This is a common reason why an image looks like it has washed out colors. In the settings, the black level is adjusted in the same way as in the previous steps. Change the value until the color of the squares is equal and completely black. The problem here is this. Are you sure that your TV is now showing completely black color correctly? Can your TV show now completely black? First, I said earlier. In HDR mode, the console can display an image in a limited mode. Therefore, first of all, set the correct dynamic range in the TV. It is very important. Without this, the black level will not be displayed correctly. Second, you may have heard recommendations to set the black level to a minimum, reducing it to 0. In theory, this is correct. But why does the black level equalize earlier, and why should it be reduced even lower? I don't know, maybe this is due to the fact that the matrix of your TV cannot show a perfectly black color. Well, reduce the value to the minimum, but check image after starting the game. If the image seems too contrasting and too dark to you, then increase the value. But do not increase too much or you will lose black color. 1 to 2 units will be enough. Let's see an example again. This wavescope displays the luminosity levels of the image. Let's say this value is the luminosity limit of our TV. If the luminosity with which the game arrives on your TV is lower than the maximum available luminosity of your TV, then your TV shows a dim picture. Look at the brightest objects like the sun. It is very dim. If the luminosity of the game, on the contrary, is higher, the luminosity goes beyond the capabilities of your TV, and your TV simply cuts off the luminosity of all objects of your capabilities. It looks like this: the luminosity of the brightest object and areas around it merge. You stop distinguishing details, and you see one continuous light. For example, you stop seeing clouds in the sky. The correct option is this: the brightness level of the game is barely close to the brightness level of your TV. That is, the sun is at maximum brightness, but all objects of lower brightness are clearly distinguishable. Everything is similar with the black level. If the black level of the game does not match the black level of your TV, then you see washed out colors and low contrast. If the black level, on the contrary, exceeds the limits of your TV's capabilities, then you see an image that is over-contrasting. The TV cuts off some of the details and you stop distinguishing details in shadows and dark areas. The correct option is as follows. Decrease the value until the darkest object becomes darker. That is, the black level is barely close to the lower limit of your TV. That is, the darkest areas have a deep dark color, but you can clearly distinguish the details in the shadows and dark areas. But as I said earlier, system HDR settings are used by only a few games, usually exclusive to this platform. Most games have their own HDR settings. Most of the problems occur with these settings. They are all different, have different names and different quantities. Some parameters may not exist at all. Let's talk about the most common options. More often than not, you start adjusting the maximum brightness range. It can be called peak brightness or just brightness or max limit or something else. But the meaning of these settings is the same: to transform the brightness range with which the game is displayed on your TV to the maximum range available to your TV. If the settings have the form in which it is necessary to discretely increase the value so that the brightness of the squares or other elements is equal, then do so. It's simple. Or another kind of settings for maximum brightness, you need to specify a specific numerical value in nits. As I said, look at ratings.com or your TV spec. But wait, you tell me. Earlier we learned that the maximum luminosity has two values: luminosity 10% of the screen area and luminosity 100% of the screen area. What luminosity is asked here? Oh, I can tell you that there is complete chaos with this. But as far as I can tell, it often refers to the luminosity of 10% of the screen area. It's okay if the value you entered is approximate and not perfectly accurate. It is more difficult if the brightness level in the game settings is indicated not in units of nits, but in conventional values, for example, Death Stranding, Final Fantasy VII Remake, etc. In this case, you will have to select the value by eye. If there is a test image in the game, then look at it. If not, just open the game. You need to find the scene or frame of the game that shows the brightest object. Usually this is the sun, lantern, fire, etc. After that, for comparison, you need to find objects with a slightly lower brightness in the same frame. For example, clouds or the sky around the sun. Try increasing the maximum brightness value. Your goal is to ensure that the brightest object, our sun, has the maximum luminosity that your TV can show. But at the same time, objects of lower brightness remain clearly distinguishable. If the sun is still dim, increase the value further. If the sun is bright, but everything around merges, clouds, sky, and you see solid light, the value is too high. Decrease the value. The next parameter that can be in the settings is paper white, which is also the exposure. This is usually the most problematic because it is absolutely not clear what image should be and what should be considered a reference picture. Here everything is adjusted by eye, as in the previous stage. Find the lightest object and the lightest one and adjust the value. See different locations, different levels of illumination. As a general rule, snow or sand should not glare like a searchlight, and it should not be as bright outside at night even under a lantern as during the day. Another option for the paper white parameter is middle point, for example, Cyberpunk 2077, Hitman series, Resident Evil series, etc. In this case, everything is simpler. This setting will shift the balance towards dark or light and still clearly show the neutral setting, which is usually the recommended setting. Often gamers, when they see washed out colors, try to compensate for this by shifting the value towards dark. It is a bad idea. If you see washout colors and your black color is gray, then the problem is something else. The middle point setting does not compensate for this, and you will also lose light exposure. This setting is only needed for small adjustments. Again, the settings can be called differently, have different numbers, but the meaning is the same. Or there are no parameters at all. And the last question I wanted to talk about is the TV settings and what to do if there are no HDR settings in the game and you can't adjust the values correctly for your TV. So, imagine you are watching HDR movies and TV shows or just HDR videos on YouTube. The original video file was most likely recorded with a maximum luminosity different from the luminosity of your TV. But the file contains metadata about luminosity. This metadata is communicated to your TV, and your TV tries to transform the luminosity of the video to match the capabilities of your TV. This is called tone mapping. Imagine if the TV did not do tone mapping, then the excess luminosity of the video and the lower black level would simply be clipped, and you would see an overlighting gray image. LG TVs have generated a lot of controversy over which is better, HGIG mode or dynamic tone mapping. You must understand the main thing. If you can tweak HDR in game or console settings, then you don't need any tone mapping, HGIG or DTM. You have configured HDR using settings. The luminosity range with which the video signal is fed to your TV already corresponds to the maximum luminosity of your TV. Stop. This is the finish line. Your parents are already proud of you. Turn off tone mapping. You don't need it. These are not movies or YouTube videos, the luminosity of which is fixed and cannot be changed. When playing HDR video, tone mapping is necessary, but it's different for HDR gaming. But if there are no HDR settings in the game does not use the console settings either, or you could not configure it correctly, then turn on tone mapping. Dynamic tone mapping tries to transform all incoming luminosity to match your TV, very high or very low. No matter how perfect the algorithms of this are, your TV does not know which scenes and which objects should be intentionally dim or very bright. Therefore, the result may not always be good. As for HGIG, let's start with the fact that the HDR gaming interest group, called HGIG, did not invent any magic technology from HGIG. Seriously. Go to the official website of hgig.org. It's on the main page. You can try enabling HGIG, especially if you've heard that this game also supports HGIG. Try toggling HGIG and DTM to find the best result. But again, if you can tweak the HDR of the game, then you don't need any tone mapping. Adjusting the luminosity to the range of your TV and turning on tone mapping after this is not correct. And of course you shouldn't try to tweak HDR in a game or console with tone mapping enabled. It is not correct. In DTM mode, there is basically no luminosity limitation. You can even serve 10,000 nits. By switching tone mapping, you change the available luminosity range of the TV, due to which the HDR calibration settings of the game are violated and will be incorrect. As for other TV settings, I said a lot in the last video. Your task is to provide a reference display with fixed settings for the subsequent calibration of the game settings for this display. If in one game you need to greatly increase the brightness or color, but in another game everything is fine with the default settings, it means that either you are setting the one game incorrectly or the one game has problems with HDR. You don't have to change the settings for each game individually. Finally, I've prepared a flowchart that I hope will help you with your HDR settings. You can also see the link in the description. I hope the information from this video was useful to you. Push like, push the bell and subscribe to the channel. Thanks to all. Bye.